Hi friends, this is Sri Mahalakshmi. In today's video, I am going to deal with integrations. We have already read about differentiation. Now, the reverse process of differentiation is called as integration. The reverse process of differentiation is called as integrations. Let us consider the previous curve. Now we are going to see how integrations are useful for us. Integrations help us in knowing the area of a given curve, area covered by the given curve. That is from 2 to 3, from x is equal to 2 to x is equal to 3. This shaded region. If you want to find the area of this shaded region, integration help us. It is the reverse process of differentiation. Let this function be y is equal to f of x. Then the area covered by this curve from 2 to 3 is given by a is equal to, this is the symbol for integration. This is the symbol for integration. Integral from lower limit 2 to upper limit 3. Integral 2 to 3. These are called as limits. Integral 2 to 3 f of x dx. This is the rotation of integration. Here these are called as, this is called as lower limit and this is called as upper limit. To know the integration, we have to know how to integrate this function, we have some formulae. The list of the formulae will be given later. This is called as definite integration. Because we know the limits from 2 to 3, we have definite values. So it is called as definite integration. For indefinite integration I, integral f of x dx. There would be no limit for this. That is, here from 2 to 3 only we are finding the area. But this is called as indefinite integration. Because the limits are not known. From there onwards, we don't know. So it is indefinite. So it is called as indefinite integration. First, we will go through indefinite integration. After that, definite integration in mathematics. If the answer for the integration is integral f of x is equal to some g of x, let it be some g of x. We don't know that function. Let it be some g of x. It is exactly g of x in case of definite integrations, and we have to place the limits from 2 to 3 like this. That is g of 3 minus g of 2. This is the way we have to consider for definite integrations. We have, if the integration of the function f of x is g of x and the limits are 2 to 3, it is represented like this, and we have to substitute the upper value first in place of x, that is g of x, minus lower limit. We have to substitute lower limit in place of x. Upper limit substitution minus lower limit substitution. This is in the case of definite integration. But in case of indefinite integration, we have to write g of x plus some c. We don't know if there is a constant. We can check the integration by differentiation also. If we differentiate the final value, we must get the function present here. That is d by dx of g of x is equal to f of x. d by dx of g of x is equal to f of x, whereas integral f of x dx is equal to g of x plus c. Now let us see the reason for getting a constant like this in case of indefinite integration. Now let us differentiate this one. Let us check we will get this answer or not. d by dx of g of x plus c, that is by the formula d by dx of u plus v, we get d by dx of u plus d by dx of v. Here u is g of x, so we must place g of x, and v is c, where c is a constant, that is like numbers like 2, 3, 4 or -2, -3, -4 or 1 by 2 or √2, like that, different constant. So d by dx of g of x b, then d by dx of g of x is f of x, and differentiation of a constant function is 0, that gives f of x. In indefinite integration, we don't know if there is a constant or not. Even if we place any constant in this place, it gives f of x only. So we must place some c. In problems also, after getting the answer, we must add plus c, so that it is an indefinite, because it is an indefinite integration. Now let us go through a list of formulae for indefinite integration.